Hey guys, welcome back to part 2 of creating this AR gallery app where the user can place pictures from their phone's photo library onto their walls. We finished off part 1 just by placing the bare pictures, but now we will get to finishing up the rest of the app. If you haven't seen part 1, make sure you do so before you continue. Let's get to decorating our pictures with some beautiful 3D models of picture frames. As mentioned earlier, a single model can have multiple materials. To wrap each picture with the frame, we essentially have to replace the material of that inner white plane of each frame with the material that we create from the image texture. I got these models from Apple's old version of Reality Composer. For some reason, they don't have them in Reality Composer Pro. The way to install the old version is to download Xcode 14, which shipped with the old Reality Composer. Then I just add a frame to the scene, modify some parameters to my liking, and export as a USDZ. I did this 5 different times with 5 different sets of parameters and have named each file as frame1.usdz through frame5.usdz. I then import them into a frames folder in my Xcode project. First, we upgrade our material from a simple material to a physically based material. We'll see why in just a sec. Then, we generate a random number between 1 and 5 and load the frame model with the same code we loaded the Earth model with. If the height of the image is less than its width, we know the image is in landscape. That's why we rotate the frame model by 90 degrees, which is pi over 2 radians. However, we also need to change the UV coordinates of our texture, which is only supported by physically based materials, which is why we made that change earlier. UV coordinates range from 0, 0 to 1, 1, and they dictate how a texture should be mapped to a mesh. Different shaped meshes have different UV coordinates. Thankfully, we're working with just rectangles today. Their UV coordinates are exactly what you'd think, with 0, 0 in the bottom left and 1, 1 in the top right. If we only rotate the model without rotating the texture coordinates, our frame will be in landscape along with the UV coordinates. These coordinates assume that the frame is in portrait. That's why we rotate the UV coordinates of the material 90 degrees in the opposite direction of the frame's rotation to keep 0, 0 in the bottom left and 1, 1 in the top right. Finally, we index into the materials array of the frame model and update the material at index position 1. I had to do some trial and error to find the right index position. Also, note that this index position is specific to these frame models I got from Reality Composer. If you're using your own frame models, your index values may differ. Just to recap, here's the full code of all of the changes. Towards the bottom, we append the new frame model variable rather than the old model variable. Time to run the app again. As you can see, every time we choose an image, it is now decorated with a random frame model. Depending on how old your device is, there may be a slight lag when you place an image. We'll optimize the performance a bit later. One elusive issue I kept on running into on my phone specifically was that some of my images wouldn't be orientated correctly. Some would be sideways or upside down. The fact that this only happened with some pictures was what made it very difficult to debug. After doing some digging, I learned that UI images have an image orientation field. Swift will usually use this value to show the images correctly when you use them in your UI, but because we're getting the underlying image data via the CG image attribute, this orientation data is lost. Think of the CG image data as the raw, low-level bitmap data of the image itself without any of the extra orientation data that UI images have. That means images aren't always stored in the phone's storage in the orientation that you see them in. The image orientation field will tell Swift to rotate the image if necessary. I assume this problem may arise if someone takes a selfie and their phone was orientated weird when they took the picture, or if they rotate their image in their Photos app. I'm not exactly sure. I don't see it happening with images I downloaded from the internet. If anyone has any specifics as to why this might happen, please let me know. That's why I had to write a couple of helper functions that take in the orientation of the UI image and create a new CG image object that has the image data correctly rotated. The first function rotates the image clockwise after taking in a multiple of 90 degrees, and the second function calls the first function. It uses the image orientation field to rotate the image the correct amount. Here's a high-level overview of what's going on. The bottom left corner of the image lies at 0, 0. Note that these are not UV coordinates. They're just the coordinates of the CG or core graphics context that we're working with. Any rotation that occurs will happen around that point. To rotate the image such that the new orientation's bottom left corner is still at 0, 0, which is necessary because that's what Swift's core graphics package expects, we need to move the origin to the center of the image, rotate it, and then translate the origin to the new bottom left corner. Once we reorientate the coordinate system to our perspective, we see that the resulting transformation was a 90-degree rotation And the bottom left corner is still at the origin, which is exactly what we wanted. The fact that these translations and rotations occur to the coordinate system rather than the actual image is kind of confusing. So just for show, on the right, I have what's happening if we apply the necessary transformations directly to the image. Let's start off with the rotate image clockwise function. Using the core graphics package might be a little daunting, especially for newer programmers, so don't fret if you don't understand each line thoroughly. I first start by checking to make sure the angle is a multiple of 90. If it's not, or if it's a multiple of 360, I just return the image as is. Then, if the orientation is not a multiple of 180, we need to switch the height and width of the image. This doesn't really matter if the image is a square. Afterwards, we create the new CG context with the appropriate dimensions. Now, we do the translate, rotate, translate sequence that was shown in the animation. We have to use the dimensions of the image to make sure we're rotating and translating by the correct amount. Don't forget that for the second translation, we're not exactly undoing the first. So we can't just use the negative values of what we had originally translated by. We have to translate the coordinate system relative to its position after the rotation. Finally, we draw the image into the rotated context and then return a CG image object from it. The code for the apply orientation function is also straightforward. I just check the 3 possible cases that would require a rotation and then rotate the image by the appropriate amount. Back in Update UI view, I pass in the UI image object to the helper function so the rotation will be applied as necessary. I'm not sure if everyone will run into the same issue as me, but the fact that this code is very modular should allow you to ignore it really easily should you not need it. Now the rotation issue is fixed. There's just one remaining issue with the frame models. The models have an aspect ratio of 4:3. But the same may not hold true for many of our pictures. Here's an example of that with a square image. As you can see, it's no longer a square. A simple solution I came up with was just to stretch or squish the frame model along the shorter edge to match the original aspect ratio of the image. Ideally, we would generate the 3D picture frames based on the correct aspect ratio, but that seemed way too complicated for this video. Maybe I'll leave it up to you guys to figure out. Anyways, we need to calculate the factor by which we scale our frame model. Here is the simple math required for that. Let's say we have 2 rectangles, one with side lengths of 4 and 3, and the other one of side lengths 16 and 9. The question we're asking is what factor do we multiply the side of length 3 by in order for the aspect ratio of the first rectangle to equal the second? It's a simple equation, and when we solve for x, we get the following. Because the image aspect ratio is always the length of its taller side over its shorter, these 4 lines of code will work regardless of if our image is in portrait or landscape. We calculate the aspect ratio of the image and divide the frame's aspect ratio by it. We then scale the x-coordinate of our model with the scale value. Now, if I try to place the square image, we see that our frame is properly scaled to accommodate for it. Another feature you guys might have been wondering about is the ability to edit a model's position after placing it, or how to remove it altogether. Installing gestures for translation, rotation, and scale is very easy, but if we wanted to delete our model after a double tap, we need to add a UI tap gesture recognizer. First, we install translation, rotation, and scale gestures. In Update UI view, simply add these 2 lines after we're done setting up the frame model object. Generating collision shapes allows RealityKit to know when a virtual object is touched, and we install all 3 gestures for our frame model. Now, for the custom double tap gesture, we'll need to refactor our code a bit. I take all the code in Make UI view and make a new class that extends AR view called My AR view. Note how this class has an instance variable named focus entity, and in the constructor, we set this variable to the actual focus entity object. This will come in handy in the next section as you'll see, but for now, don't worry about it. At the bottom of our constructor, I create a new UI tap gesture recognizer and pass in a delete image function. I also make sure it requires 2 taps to activate and add the gesture recognizer to the class instance. The delete image function is simple. The reason we had to create a new class though was because this function needs to be exposed to Objective-C, which isn't compatible with the AR view container struct. In this function, we first get the point on screen where the user tapped. Then we query the scene to see if there is a model entity at that point. Finally, if a model entity was found, we take its anchor and remove it from the scene. After these changes, if our user makes a mistake while placing an image, they can easily fix it. A bug that might have slipped you guys happens when you try to place an image if there is no vertical plane detected. In that case, the model will just pop into the scene the next time a vertical plane is found. We don't want the user to face this ambiguity. Let's quickly fix that along with the fact that we want the focus entity to disappear if the user chooses to hide the photos picker, just so the user can enjoy their AR scene uninterrupted. We can fix both of these issues in just a couple of changes. After importing the combined framework, which we'll talk about in just a sec, we create a new state variable in content view named planeDetected. We also pass in the show photo picker and planeDetected variables into our AR view container now. Then, when the user selects a photo, we also check for if a plane has been detected. Otherwise, we just clear the photos picker like normal. In AR view container, we add these variables as binding instance variables along with a new scene observer of type cancelable wrapper, which we define under the struct. This is because each frame we want two things to be updated, whether or not a plane has been detected by our focus entity and if we even want to be showing the focus entity. The easiest way to do this is to subscribe to sceneEvents.update, which is an event that runs every frame and can change the state as necessary. The reason we can't update these values in update UI view is because it results in undefined behavior. Because we're subscribing to this repeating event and will run our own code with it, we need to store the subscription, called a cancelable, in a local variable, otherwise it'll be deallocated by Swift, ending our subscription. Feel free to read Apple's documentation about the combined framework if it sparks your interest, or if you want more information on it. However, because we're unable to change instance variables in Make UI view, we simply wrap a cancelable variable in a class and access that variable through an instance of the cancelable wrapper class. In the update scene function, which we pass to the sceneEvents.update event, there are two things that happen. First, we set the isEnabled property of the focus entity to the show photos picker variable, essentially tying the two together. Second, we update the planeDetected state based on the onPlane property of the focus entity. And just a reminder, this update scene function is now going to run every frame in the background, constantly updating these state variables. If the user now tries to place an image when there is no vertical plane detected, nothing happens. If you guys would like to improve the user experience and show a pop-up message when this happens, feel free to add that in as well. Toggling the photos picker also toggles the focus entity, so the user can truly immerse themselves in their AR gallery. The final issue I want to fix in our app is the tiny lag that occurs whenever we place a model. This could be exacerbated depending on how old your device is. The reason for this lag is because we're currently loading our models synchronously, which freezes up our main thread anytime a user places an image. RealityKit actually has functionality that can let us load a model on a background thread instead, leaving the main thread uninterrupted. First, I create a new frame model class. Its instance variables are its name, the model entity after it's been loaded, and a cancelable that stores the subscription to the asynchronous loading of the model. Again, we're using the combined framework here if you take a look at the imports. To load the model, we call modelEntity.loadModelAsync and pass in the file name. We handle for a potential failure, and upon success, we store the newly loaded model entity object into the frame model's model entity instance variable. I then create a new frame model picker class that will instantiate 5 frame models and store them in a list. I've also added a helper function so we can randomly sample out of the 5 models. To use the new frame model picker object from the AR view container, we simply make a new instance variable and instantiate the frame model picker. Then, instead of randomly generating an integer and loading the model synchronously, we replace it with a call to get random frame model. Upon running the code, our app should feel a lot smoother. This is because all of the 5 frame models are being loaded asynchronously right when the app is launched, so when the user places a picture, the 3D model is all ready to go. Now you can turn any room in your home into a beautiful picture gallery. There are so many other features of ARKit and RealityKit that I haven't covered, such as the ability to photo scan objects, saving a scene to restore it later, or shared experiences so someone else can visit your gallery from their phone. If any of those features intrigue you and you would like a video on them, let me know down in the comments below. It's really cool to see how many features RealityKit and ARKit have for us just to pick up and use. I mean, could you imagine how challenging this app would have been if we had to manually write the plane detection or LiDAR code, not to mention 3D modeling each of those individual picture frames by hand? Using AR on our phones is really cool, but having a headset would be the ultimate experience to enjoy your new art room. I understand that augmented reality poses a very intriguing challenge with a limited compute budget, and that's why I can't wait to see what future generation headsets have to offer. But now I hope you guys are able to enjoy your AR gallery and have just as much fun with it as I've had. Thank you guys so much for watching, and I hope to see you guys soon. Bye bye.